All right, thank you. Our next block is lightning talks, so I'd like the three lightning talk authors to come up to the front. I'll just remind you that the order is going to be Jeff, then Shelley, and Jim. As a quick program note, lightning talks are 10-minute or less introductions to a topic, so they may generate some questions, but unfortunately we don't have a lot of time to go into detailed questions. So I ask that you hold your questions, and we'll give you the chance to catch up with the speakers afterwards here near the podium or perhaps at Beer and Gear. So to get us rolling, Jeff, could you come up and talk about the DNSSEC route?
Right, good morning all, good afternoon all, 10 minutes. Right, this is all about how to kill the internet in 2,000 bits. No, not really. This is about some impending moves around the DNS to change the trust anchors that are used inside DNSSEC. 5 years ago, after much fanfare, ICANN's root signing service started in operation. Grand ceremonies all over the place, lots of fanfare. All of a sudden, the root of the DNS was actually signed, and that actually allowed everyone else to use a single trust anchor to do validation. It's all very serious business. The keys are held in some fantastic facility somewhere in the eastern hemisphere of this world. That's on the eastern side, and of course, over the west, Californians do things differently. This is the repository there. What is a key signing key? What is a KSK? What we do in the DNS with signing is actually split the whole problem into two parts. There is a key signing key whose basic job is to sign a zone signing key. And the zone signing key signs the individual root zone entries. The zone signing keys change, I think it's every 3 months, they get regularly rolled. And that happens automatically because the key signing key gives you constancy. The key signing key is the trust anchor. And anyone who validates has a copy. So if we're going to change the key, all of you have to change your copy, and that's going to be a bit of a challenge. So the private key stored inside some massively secure HSM, blah, 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 it's all very good. No key lasts forever. Well, that's what we're told by the security folk, so, you know, who am I to argue with security folk? They're bigger than me and they beat me up. So the idea is, at some point, regularly, you do need to change over to different technologies and a different key. Short keys over time get weaker, cracking gets better, we need longer keys. So the commitment was made back in 2010 that we would roll the key in 5 years. That was 5 years ago. This is now, it's time to change. So the cast of actors, this strange mix of politics and technology, as you'd expect from the DNS, we deliver on every front. So not only is ICANN involved, but of course the US government through the NTIA is involved, and of course VeriSign is involved. And just to add some fun, folk like me are involved as an external design team. They think it's a point of sanity. I'm not sure that's true. So the approach, we've been at this for some time in looking at this. There was an initial public consultation in 2012, a detailed engineering study the year after. The Security and Stability Advisory Committee put out a document in 2013, and this year the KSK role design team has been set up. And here are them. I think I'm providing the entertainment to the other serious workers. The rest of them have a long and deep track history in the DNS. I just measure things. And of course, as well as that group, the root zone management partners are also there providing advice, assistance and material. So what have we been doing? Well, since January we've been studying, discussing, pondering, more pondering, more pondering, bit more discussing, more pondering. You sort of get the picture, right? In June, shit, that's now, we have to write a draft report and present it for ICANN public comment. I should be typing, shouldn't I? And in July, after that public comment, we'll prepare a final report and then pass that through to the root zone management partners. All very good. This is bureaucracy at work. It's fantastic. However, underneath that is a serious issue because everyone has a copy of that public key signing key. Everybody. And everyone needs to load a new copy. Now, if you look at the ecosystem of the DNS out there and you look at some resolver behaviours, some resolvers still are running on what I think are TRS-80s. There is some awfully old code out there, and when you start mucking around with trust anchors and trying to get folk to reload things, this is sometimes getting them to go down into the crypt and break open the seals to get a box that you just thought was running and you'd leave it alone and fiddle with it. It's a recipe for disaster. And of course, we've had some experience in rolling keys before. In 2010, the dear folk at the RIPE NCC, every 6 months they rolled the key. Every 6 months, the traffic on their resolvers sharply increased. Why? Because a Linux distro was sending out old keys. And DNS resolvers, being the obsessive compulsive bits of software they were at the time, didn't like the idea of validation failure. It just tried and tried and tried and tried and tried and tried. And the poor old authoritative name server's going, enough already, can't you take a no? Since then, obviously, we've learned so much more and we're so much better at this. And one of the bits of magic that we are relying on to make all this work is RFC 5011, which is basically old signs new. So as long as you're doing RFC 5011 in your resolvers, this will just work. Seriously. Must keep a straight face. This will just work, because what will happen is the old key signing key will sign the new key signing key. Your resolver will see this chain of trust and go, perfect, I will now store this new value as my trust anchor. We will move on. And then at some point we will publish a revocation of the old one, and that's just fantastic. And to prove that it's going to work, here's a colour version of the same thing. Obviously it's going to work. So what does it take? Well, you publish the first key. Now this gets a little bit interesting, because all of a sudden the responses to your queries, which were 736 octets in size, jump to 1011 octets in size. Interesting. And then we start doing the first of these. The new KSK starts signing with the old KSK. The DNS response size without the packet headers, without UDP or IPv4 or v6, the DNS payload is 1,297. That's bigger than 1280 v6, folk. That's bigger, which does mean there might be some issues around there. We run the two for a while, we remove the old KSK, but don't revoke it. There is still a small amount of breathing space, and we revoke it a little bit later, just when we're sure that we've actually managed to do this. At the top there you see this rather optimistic Q1, Q2, Q3, Q4. They're just guidelines, they're not rules. So, some technical concerns. Who doesn't support 5011? I don't know. I'm not sure you know, but you will know, because when the key changes, you really will know. Because when validation fails, that resolver won't be able to answer anything. How many of you cope with responses in v6 larger than 1280? Well, I know, and it's not completely true that everyone copes. A few of your resolvers are not very good at this. You also use eDNS0 buffer sizes that even when the response is less than 1500, some of you don't like it. You go, no, anything bigger than, say, 900 is too much for me. How many resolvers will get stranded by even 1297 octets? And of course, how can you bench test your resolver against this new role? Well, firstly, some numbers. You know, if v6 was like this, we'd all be, retired and finished. It is amazing how much DNSSEC is out there, almost unconsciously. 90% of unique queries, when we do samplings, 90% of those queries actually have the eDNS0 set and the DNS set OK bit. As soon as you sign a zone, everyone loves your signature. Almost everyone gets a copy of your signatures. 1/4 of the world will validate your signature. 1/4. They will validate. But only 1/2 of those like what they hear and will stick with it. If I give you a badly signed piece of DNS, one half of you go, no, you weren't meant to badly sign. I'll just go and ask some other resolver that doesn't validate anyway. So, you know, some of you just simply go, oh, stuff this security business, I really want the answer. Some 8% of you don't seem to think 1,500, seems to think that 1,500's too big. 8% of you walk over to TCP when the size gets big. And that's one of the changes that will happen across the sign-over and then will disappear again. Because what we will see is around 8% of resolvers will not actually do this in UDP. How many of you support RSC 5011? I don't know. We don't know. So, what do you need to know? What would you like to know? That's what we want to know. So, you've only got 1 second to ask a question. That's not going to work. Send me mail, send the design team mail, get in touch with us. We're happy to hear your concerns and try and answer your questions. Thank you.
Thank you, Jeff. So Shelley with new patterns in streaming telemetry. Correct?
You got it.
All right, thank you.
Telemetry literally means remote data, data at a distance. And when you're talking about data about your network infrastructure, it is by definition telemetry, because there's a gap between where the data is sensed and measured and then where the data is stored, searched, analyzed, visualized, and turned into information upon which you can take meaningful action. Bridging this gap, we have many technologies. The warhorse is really SNMP polling here. Where you can't find the MIB, you might fall back to CLI and screen scraping. And for event-based data, you'll grab some syslogs. Now, looking at all of these, I'm sure each of us have a list of pet peeves about them, but we understand that they all have weaknesses. So for SNMP, there are transport inefficiencies built in to doing a poll. For anyone who attended the network automation tutorial this morning, I think you have a really good sense of how much work goes into writing regular expressions to parse text and strings from CLI and from syslog, and how difficult that is. So each of these mechanisms that we rely upon have individual weaknesses. Collectively, they have weaknesses as well. If you look at, they all come in different encodings, in different transport mechanisms. The timestamps probably look different. There is a huge burden on the back end to normalize that data so that it can be put somewhere so that you can do your analytics to start with. Now, the title of my talk had the word new in it. There is nothing new here, right? This has been the status quo for over 20 years. What is new is the environment that we're operating in. Back when SNMP was first standardized in 1988, you guys, okay? There was no sense of data warehousing or data centers that were the size of warehouses. We did not have the kinds of tools that we have today for consuming and analyzing big data. More importantly, the requirements in the network have changed. Obviously, we're operating at speeds and scales that weren't conceivable in the 80s. With the advent of SDN, we're centralizing more of our control, which means we need to centralize more of the data that we understand about the network. And to give specific examples of use cases, some of which we've seen during the talks here this week, traffic engineering and WAN optimization used to be things that we would do on the order of weeks and months. And now we're thinking about how do we do this on the order of hours or even minutes. Troubleshooting is no longer about doing something reactive after the fact, after the network has failed, but doing fault prediction and ultimately doing automated remediation. So we have tools and capabilities that can deal with lots and lots of data. We have emerging use cases for the network that require lots and lots of data. So now all we have to do is get lots and lots of data from the network. And once we do that, monitoring turns into a big data problem. So back in the olden days, right, if you were thirsty, you got a bucket and you walked to the well and you scooped up what you wanted and you walked back. Well, today there's a miracle that happens that you can just turn on the faucet and get a drink, or maybe a different kind of drink that you guys might be thinking of right now. If we take this same analogy and apply it to the network, what we want to be able to do is go to the devices on our network and turn on the faucet. Describe what it is the data that we want to collect, how often do we want to collect it, and where should we send that data, and then the faucet should just turn on and that data should come to us. Now, based on some of the work that we've been doing in this area, I think we've come up with some fundamental principles, or I think these are emergent principles, really. First of all, that we must enable a push mechanism for telemetry from our network. And it's useful just to eliminate the polling cycle of an SNMP GET, first of all. That's very useful, even in and of itself. But one thing we understand as well is that telemetry can't just stop there. You have to go to every layer in the architecture of that device, all the way down to the hardware, to deliver information about each layer in the network out to your collector. It is table stakes that this must be machine consumable output, right? We cannot be writing regular expression until the end of our careers. So this must come in a format that's easily parsed by tooling and automation. Beyond that, I don't think we can be prescriptive, right? Some of this data might be self-describing. In other cases, it might be schema described and put into a binary format. Self-describing is a little bit chunkier on the wire, but it's more convenient and easier to use, whereas binary encoding may be the most efficient wire format. Absolutely, the thing we must remember all the time is performance, 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 right? The cracks in SNMP started to show up when we went to high-frequency polling of a large diversity of data. So if you ever forget about performance, then you've lost the value of streaming telemetry. Finally, and maybe most importantly, is that we have to be flexible and adapt this data to the existing tool chains, right? This means that the format must be flexible, the transport must be flexible. I mean, think about it. If we said today, all of this data will be encoded in ASN.1 and will be sent over UDP for the next 20 years. I mean, that's insane, right, given the speed at which tools are evolving around big data analytics. But that's exactly what we did with SNMP. And so, and importantly, since so many of these tools are open source, whatever data comes off must be easily consumable by open source tools. To give you an example of some work we've been doing, this is an example of a link polarization type of use case in troubleshooting. The blue and the green lines represent traffic utilization from two links in a bundle. And when those two lines track each other, things are normal, that you've load balanced appropriately across the links in the bundle. But when they diverge, which you can sort of see halfway through that chart right there, there's a problem, right? There's an imbalance in the traffic you're sending on that bundle. And a better way of looking at it is probably the line in red, which is just a simple coefficient of polarization that you can calculate from those saved numbers. When it goes high, something is wrong. Now, this is the type of failure that if you're polling at 5-minute intervals, you may completely miss this, right? Or even 2-minute intervals. But if you can send this data off the box much faster than that, then you can easily throw it into an open source tool. And with minimal work, really this was minimal work, you can start to get useful and actionable information out of your network. Now, those are the known knowns. There's also famously the known unknowns, right? And there are things that I don't think that we completely understand today. First of all, how is it that we specify what we want? In SNMP, you have OIDs, right? And they may be complex and difficult to figure out, but at least you have a specific name for the data that you want to get. How do we do that if we move away from SNMP as a model? And I think we'll have some talks tomorrow that'll give us some ideas about that, but it's an area open for discussion. Another area would be around flow control. With streaming, do we just assume that the receiver has infinite capacity, or do we need some kind of squelch mechanism in there to stop the flow? Do we need to do filtering on the device? Do we need to do aggregation? Do we need to calculate deltas instead of sending absolute values? Those are open questions, I think, about what we do on the box and then what we do off the box at the receiver. There's a question, too, around what is the ideal frequency. I think some people would be absolutely thrilled if we could give them every statistic they wanted every 60 seconds. That's a challenge for SNMP in some use cases. So if we could get to 60 seconds, a lot of people would say that's a win today. But what about 2 years from now, or 5 years from now, or 10 years from now? How should we be streaming this data off the box? At what point also does it get ridiculous, right? I mean, if we're doing millisecond streaming of statistics on the box, is that too much? Do we need to, find a different way of solving that problem and not use streaming telemetry as a hammer? The other thing is, I talked about turning on the faucet, giving that device instructions on what you want. You can do that statically, but eventually we need to move to a dynamic way of publishing and subscribing the capabilities of the box. So these are still things that need to be worked out. Finally, there are the unknown unknowns, right? And this is potentially much bigger than either of the other two categories. And all I have to say about this is the way that we're going to learn these things is through experimentation. It's through getting code in the lab, getting the data off the box, interfacing it with open source tools, and so on and so forth. So I think this will be, and has been so far, a very iterative process, and it's one that we proceed through stages. So the things that I'd like you to take away from here is that we believe that streaming telemetry has utility and traction. There's interest in this. There's a lot of conversations going on about it. But it's still a very young technology, and so there's an opportunity for you guys to have an influence to put in your pet peeves and things you'd like to see, and we can have a discussion. So I hope that starts today. Thank you.
Hi, I'm Jim Martin. I'm with ISC, and I want to talk a little bit about DLV. DLV is DNSSEC look-aside validation. It is a mechanism that was developed early in the life of DNSSEC in around 2006 with the objective of trying to get around the chicken and egg problem of not having the tree signed up to the root. It was a repository for all of the key information that was off to the side and had its own separate trust anchor. It was a great idea at the time, and it has served its purpose for many years. But a bunch of things have happened since then. We started with, when it started, there was one CCTLD that was signed, the .SE guys. But since then, we've had a huge number of CCTLDs. We've had the root finally get signed. We've had a number of the original TLDs, ComNet, all of those guys signed. And we also have had a lot of the recursive resolvers have become DNSSEC enabled. And we're to the point where we've got quite a few of all the infrastructure pieces in, but we still have DLV around. So led us to the question of, are we doing a benefit for the internet anymore by running this repository? The advantages of having it around is that if your parent isn't signed, it still works. And it doesn't cost you anything. And it is all fully deployed at this point. But it was reducing the pressure on the few remaining TLDs that aren't signed to sign. And it reduces the pressure on the registrars to accept the DS records there because, well, you still can go over there. And frankly, there's some additional work that the resolvers are having to do by going off to the DLV entry. So we're looking at who really still needs it. So who needs it are the people whose parents are not signed, the zones whose parents are not signed, and the people who have registrars who don't have the ability to accept DS records. So let's look at those. If you look at the graph, it's pretty clear that the uptake of signing of TLDs is going up dramatically. We've got more than 3/4 of them signed at this point, and there's no indication that there's going to be a big problem getting the last one signed. And also, on the registrar side, again, a very large percentage of the registrars support DS records, but for those who do not currently obviously have it through the web interface, many of them still accept it through an email. And if anybody who's re-signing with ICANN, the new registrar accreditation agreements require that you accept this information. So if DLV weren't around, it would require some people to switch registrars if they want to continue being signed, but this is considered a pressure point. So we went through the checklist. We said the root's signed. We've got a whole bunch of the TLDs are signed. A lot of registrars are supporting DNSSEC. And we think that announcing the sunsetting of DLV is going to increase the pressure on the registrars who don't accept DS records. So it's really just trying to deal with that one last issue. So this is what we're planning on doing. We're going to start by cleaning up the zones. We've got about 4,500 zones in the DLV right now. Of those, only about 2,800 are actually working. The rest of them were all partially set up, don't have valid keys, just aren't valid. Of those nearly 3,000, only 397 of them are ones that could not be, that could not have DNSSEC records all the way up to the root. As in, 400 or so of them are ones that their parents won't be signed. Of the 3,000, also, 20% of them already validate all the way to the root. They just haven't pulled their information out of the DLV. So we're going to work on cleaning that stuff up. And then eventually we'll stop adding new zones, and eventually we'll remove them all. And here's the timeline that we're planning on working on. So today, within the next couple of weeks, we're sending out some emails to people who are in the DLV right now. So if your zone is already validatable all the way up to the root, everything's good, we're asking people to remove their zones out of the DLV. Then also, if you could potentially be validated up to the root, but you just haven't given your information to your registrar yet, we're asking you to do that as well. This is all just a request at this point. No changes are being made to the infrastructure at this point. At the beginning of 2016, we're going to stop accepting registrations for zones that could be validated outside of the DLV. Just don't want to have any more contributions to the problem. In the middle of 2016, about a year from now, we're saying that no new users and no new zones can be registered in the DLV, and anybody who we warned in this email that we're about to send out that is going to go away, we're going to purge those records. And then ultimately, at the beginning of 2017, we're going to purge all the records in the DLV except the SOA record, and the zone itself will stick around for forever, or for our definition of forever, but there will be no records in it whatsoever. So the goal is by beginning of 2017 that the DLV is going to be gone. The main reason I'm here is to make sure that you guys all understand that that's happening, and that if there is pushback, if people believe this is a bad idea, we want to hear about it now rather than later in the game. So if you do have any questions or comments, please email to dlv@isc.org or ask questions now, but I think you're far more likely to go when I have a beer. Thank you.
All right, I did ask the speakers just to wait around for a few minutes, so if you do have any questions when I finish, please feel free to come up and ask them briefly. As was mentioned, we're heading to Beer and Gear, which is down in the Californian in Elizabethan room. I think you can follow the people leaving, but go out the door, turn right, pass registration, turn right again, and it's down there. Tonight we do have a social at 8:30. And you can get the information on the website, but it will be at Jones, and it's being hosted by Facebook. So thank you, and we'll hope to see you at socials and back here tomorrow. Thank you guys all for being here.
Sure. Between us and beer, come on.
Yeah, right.